In this video, we are graphing systems of inequalities, which means we're going to have a shaded region of solutions. So in this equation, y is less than or equal to the square root of x. Because it's equal to, it means it can be right on the line. So I'm going to go ahead and graph this equation. I have y equals square root of x, so if I plug in a 0, I get 0. And maybe I'll write this out for you. If I plugged in a 0 for x, I got 0. If I plugged in a 1 for x, I would get the square root of 1, which is 1. If I plugged a 2 in for x, that would give me approximately 1.4. If I plugged in a 3, I would get approximately 1.7. And if I plugged in a 4, the square root of 4 is 2. So I have this line that's curving up through here. Looks about like this. Now, I am going to shade in everything that's supposed to be less than or equal to that value, all of the y's. So if I take all of the y's, meaning what are all the y values that are less than or equal to this line? And that would be all of these values down here, right? So I'm going to go ahead and shade those in, but realize that these are only the values that work for just this top equation, right? And realize that it doesn't go past, on the left, it doesn't go past it doesn't go past the y-axis because we don't have our function below 0, right? So that's why it stopped right here on the y-axis, because this function doesn't keep going, it stops right there. So we have all this stuff shaded in, and it would keep going to the right forever and down forever. Now we're going to graph the second line, which is x is less than 4. Now because there's no equal sign, we have to graph a dotted line. So we have a dotted line that's going down where x is equal to 4. So if we go to 4, here's our dotted line. We're going to go draw a dotted line going straight down where x is 4. And that's because all the values along this line, all the x values are 4. The y values are changing, but the x values are always 4. And we're going to shade in everything that is to the left of 4. Or in other words, all the x values that are less than 4. Which means we would have the entire section everything less than 4. So this whole thing, everything less than that. So that's all of this stuff over here. So graphing these two things separately, notice that we have all of this stuff over here. This is all of the x is less than 4. And this stuff in the green is the y is less than or equal to the square root of 4, of x. Now, notice there is a section that is double shaded. This section here, which will continue down forever, right? The section that is shaded, this section here, is your solution area. Meaning that this is the only area that you really should be shaded. All right, so there's your solution area. So when we do actually shade in these things, we don't want to shade all of the areas. We only want to shade in the area where both of them would be shaded. Meaning we're only going to shade in this portion on our graph. This is the solution area, and it will keep going down forever. So any point inside of here, inside of our shaded region, will satisfy these two equations. So if I picked a point, say this point right here, of 2, -1, the x value of 2, if I square rooted 2, that would be bigger than -1. Or in other words, -1 is less than square root of 2. And also, if I plugged in 2 to this equation, 2 is less than 4, so it does satisfy both of these equations. It satisfies our system. All right, notice now our system, we have 3 equations. So the first equation, y is greater than -1, which means I would go to my spot on -1. It was a dotted line because it's not equal to. And it would be everything shaded above that. So I would have this everything from -1 shaded above. All of this would be shaded in. Then I would go to my second equation. And my second equation says x is less than 1. So that means I would take and draw a dotted line right where x is 1. All values for x equaling 1, which is going straight up and down. And I would be shading in everything that is less than that. So I would be shading in all of this stuff over here. So you can see now that we've already got a section of our graph where it's double shaded, meaning so far this point, this stuff over here would be what I would shade on my graph. Now I have a third line where y is less than or equal to -x squared plus 5. So -x squared plus 5, meaning it's up 5 spots. It's our -x squared function, meaning it's our u shape that's pointing down. And so I would plug in my points. I could plug in a -1 and I would get 4. I could plug in a -2 and I would get 1. And I could plug in a -3 and I would get -4. So I have this function. And I would be shading the things inside of that function. Now, as we look at this, you see this area right here. This area right here is where we have all of the shading. All of these pieces are shaded. So when I am actually doing my assignment, that portion is the only portion that I do shade. I would only be shading in what's below this function, above my y is equal to -1, and to the left of my x equals 1. So this is the only section that I shade in. That is my solution area. Sometimes it's helpful to draw arrows. So as I'm putting in my y equals, or y is greater than -1, sometimes I like to draw up arrows because it's greater. X is less than 1, so sometimes I like to draw in my arrows pointing to the left so that I know that it has to be left of those. And then when I'm drawing in my -x squared plus 5, I would draw arrows going down so that I know it has to be below that. So it's below this